Right. Okay, let's start the discussion for the test paper number 3, right? Okay. In the first question, an object is projected upward with a velocity of 100 from the ground. If the air resistance is neglected, it will strike the ground in, right? So in this question, a ball is thrown vertically upward, and what happened? It will return to the ground, right? So the question is asking about the time which is taken by this object uh, to come to the initial position, right? So if the object come to the initial position, so let's apply an equation from vertically upward. The question is asking about the time, right? And we can able to obtain an idea about the displacement of this object as 0, right? So if you have any idea about the displacement and the time, what is the best equation that you need to apply? It's obviously it's equal to t plus half at squared. Then x equal 0, you mean 100, time is the unknown term, half. Okay, when you substitute acceleration, it should be minus 10 into t squared. Then, so then is come 100 equal, sorry, 0 equal 100t minus 5t squared. Then we can able to obtain an answer for the t as 20 seconds. So the answer should be the fourth one, right? In the second question, consider a following statement made about the motion of a particle, right? A, velocity of a particle cannot be reversed without changing the direction of its acceleration, right? So they just go through this statement very carefully. Velocity of a particle cannot be reversed without changing the direction of its acceleration. So they, let's assume that an object is moving toward this direction, right? And it is accelerating toward this one. So if you want to change the direction of this, change the direction of the velocity, that's mean you have to given a force towards the opposite direction. So the A statement should be correct. That is, the velocity of a particle cannot be reversed without changing the direction of its acceleration, right? So it's obviously correct. You might think that let's assume an object is moving vertically upward and then it's returned to the initial position as in the first question. Then now in this question, the from A to B, the velocity is directed vertically upward, and when it returns to this B to C, the velocity is directed towards the opposite direction, right? So then here, when the acceleration is always exerted towards the ground, right? But here, now what happened when the object is moving upward, the velocity is getting gradually reduced, right? So that's mean it should be because the gravitational effect is exerted vertically downwards. So these are two different examples, right? So however, the A statement should be correct. Then B, when a particle is projected vertically downwards with a large initial velocity, its acceleration will exceed the acceleration due to gravity. Right. Today, this one is a false one because even though we are given a huge value of initial velocity, the object is moved downwards with the gravitational acceleration, right? Because you can't able to change this value. So the obvious, even the object experience or obtain a huge initial velocity, it is moved towards the ground with the gravitational effect, right? So the B statement is incorrect. And the C, when the acceleration of a particle is zero, it must be necessarily be at rest, right? So then you have heard that, and let's assume that according to the Newton's first law, he mentioned that unless exerting an unbalanced force, the object can be at rest or it can be moved in uniform velocity, right? So that's mean there's no any unbalanced force mean that the acceleration is equal is zero. So even though acceleration is zero, object can be at rest or it can be moved at constant velocity. So they mention that only this condition, but you have to think about this one also, right? So even the acceleration is zero, object can be moved with the uniform velocity, right? So the C statement is also incorrect. So the B and C are false ones. So the answer should be the second. Right. In the third question, a particle moves first a distance with a uniform velocity of v and next a distance with a uniform velocity of 2v. What is the average speed of the particle, right? So initially, first a distance object travel with v constant velocity. After that, object increase the velocity up to 2v and move with the a distance, right? So question is asking about the average speed. Puthe, you know that average speed can be obtained by total distance over total time which is taken to complete the motion. Now, according to this given data, the total distance can be substituted as 2a. So then you have to obtain a value for total time, right? So how to obtain the total time? Now, the question is mentioned that this motion is there are two types of motion, even though the object is moving in a constant velocity, right? So then let's call this 3 points as ABC. So if I apply an equation from A to B, it's obviously S equal UT because the object is moving in a constant velocity. Then let's assume that time as T1. So then we can able to obtain a value for T1 in terms of A and B. Right. So let's apply then another equation to BC motion. The same equation, then the displacement, the distance is equal, but the velocity should be 2v. Let's consider the time as t2. Then it is equal to a over 2v. Right. According to this obtained equation, let's substitute it. A over v plus a over 2v. Then let's consider an common denominator as 2v, then it should be 2a plus a, that is 3a, right? So then these are cancel each other, then we can be able to obtain an answer as average velocity 3v over 4. So the answer should be the third one. Right. In the fourth question, the figure shows the velocity time graph for a particle which starts from rest and moves along its direction according to this graph, right? This is a given graph. Right. A particle comes to rest only at time t3. No, because today now this graph represents the velocity time graph. So you can able to figure out that the t1 should be at here, and this is the t2. You can able to figure out that at the t2 and t3, the object come to the rest. By so just concern the y-axis. So when the y-axis, this graph is become 0. Uh, So when the y coordinates become 0, okay, that's mean velocity becomes 0, right? So you can able to figure out that the velocity is equal to 0 at this line. So when the graph is come to this certain point, that's mean the velocity obtained is 0. So this object obtained t2 and t3 times at the T2 and T3 object come to the rest, right? So the first statement is A statement is incorrect. The particle returns to its original position at the T3, right? So then, you know that. Let's consider an example. Let's take an object move from A to B and returns to initial position. Initial position, right? So if we draw, let's assume that the object is moving in a constant speed from A to B and it's returned to the initial position. So if I draw a graph for this particular motion, let's assume that so in this, I will explain this question as object initiate the motion. No, that's fine. Let's assume that object is moving in a constant speed. Right. If I draw a relevant graph for this motion, this one should be constant from A to B. And then what happened? The velocity is directed towards the opposite side. So then it should be draw like this, right? However, the area of the velocity time graph represents the travel distance or the displacement. So this area represents the distance travel toward this direction. That's mean let's call it as x. Right. So the x is represented by the area of this graph, right? Then, if the object is returned to the initial position, the second half, the displacement travel in the second half also equal to the x. So that's mean the area of this shaded region should be equal to x. So then next mean today, in a given velocity time graph, if the velocity in the positive y axis and the negative y axis are equal, that means object return to the initial position. But when you go through this graph, you can able to figure out that this area represent the distance travel toward a certain direction, and the below area should be represent the opposite one. Let's call this S1 and S2. So you can able to figure out that if you concern the area of these two graphs, the area of the this triangle should be greater than the other one. So then obviously S1 should be greater than to the S2. Then we can be able to come to a conclusion that the object cannot be returned to the initial position. If the object is returned to the initial position, then the area of these two graphs which is shown in the positive direction of the y-axis and the negative direction of the y-axis should be equal, but it is not fulfilled or satisfied in this certain given graph. So the B statement should be false one. C, the particle accelerate only during the time 0 to t1, right? So then you can able to figure out that So I will erase this one, right? Because I will draw this graph to given some idea about the area. Here, we can able to obtain that from 0 to t1, object accelerate. That's mean the velocity is getting increased. But uh, then you can able to also you can able to obtain that this uh, this time also from this certain graph also object no sorry, accelerating velocity is getting increased no today. Now if I given some letters for this equation, you can able to figure out that from A to B, velocity is getting increased. So that means that's acceleration. From B to C, the velocity is getting reduced. So that means it's a deceleration. But from C to D, you can able to figure out that the velocity is getting increased in a negative direction. So that means it's obvious here acceleration, right? So CD part is also can be considered as an acceleration. So the C statement is also incorrect, right? So the answer should be the first one, right? In the fifth question, an object dropped from a height h, bounced back from the floor to a height h over 2. Which of the following velocity time graph best represent the motion of that object, right? Right. Okay, if I draw a certain diagrams relevant with this question, object is dropped. Okay, drop mean initial velocity is equal to 0. Right. So when you know that when the object coming towards the ground or when it's move vertical downwards, what will happen? The velocity is directed towards this direction, and the velocity is also is getting increased. That means it's acceleration, right? And initial height of this object is h. Then what happens when it's after collide the ground? It is move up to a certain direction. That means h over 2. Right. So call this A, this one is B, this is C. Right. So then after that, so also is coming towards the ground. Then, however, from A to B to there, the velocity is directed towards the downward direction. But when it's move upward, the velocity is directed vertically upward. Right? So there are some certain things that you need to know when you obtain the answer for this question. First one is when the object is coming downwards, the velocity should be directed vertically downwards, right? So when after bounce, uh, the object is moved vertically upward, so then the velocity should be directed vertically upward, right? So that's the thing that you need to identify at the when looking at this diagram, right? So then uh, the direction of the direction of the velocity are opposite. Velocities are opposite. Because at the first instant, the velocity is directed downwards, and the second instant, the velocity directed upward direction. Right. The other thing is now this object is moved due to the gravitational effect, right? So then, obviously, this object experience from A to B uh, an acceleration, and when it's moved upward from B to C, object experience and deceleration, even though the magnitude of the acceleration should be equal, right? So then, even though the object experiences an acceleration from A to B and the deceleration from B to C, the acceleration should be acceleration is equal, right? The other thing is you can able to figure out when it's come from A to B, object travel with a distance of h. So when it's moved from B to C, object travel in a displacement of h over 2. So that's mean this displacement are two different values, right? Okay, then let's draw the relevant graph for this motion. Okay, now let's assume that down the velocity which is directed downward direction as a positive, and this object moving from A to B, the velocity directed vertical downwards. So this should be a in a positive velocity. So it is starting from rest and it is accelerating with a constant value. That means this is the relevant graph, right? Then what happened? This is the AB representation. So what happened from the B to C? The velocity is the direction of the velocity is getting reversed. That's mean, and so also you should know that. Just assume that now when you move upward, the velocities gradually become reduced, and at the C point, velocity should be zero. So however, the velocity at the C point should be zero. And the velocity is opposite, and it is when it's moved from B to C, the velocity is gradually reduced. That's mean today, when we draw this diagram, this should be something like, right? Still not the final answer, right? Because now the gradient of this graph represent the acceleration. So if the acceleration in both instances are equal, then today this graph should be parallel to this one. Acceleration is equal, magnitude of the acceleration is equal AB graph should be parallel to BC graph. The other thing is I explained that the displacement of the object travel represent the area of this graph. But you know that this the area of this graph should be represent the h, and the area of this graph should be represent the h over 2. Hence, then the area should this area should be greater than this one, right? So that this is not the correct one. So best representation of for this motion is this is the best representation of for this question. So the answer should be the first one, right? So the answer should be the first one, not the second one. So what is the reason for not being taken the fourth one as the correct one? Because you can able to figure out that the lines are not parallel each other. So that's why I'm rejected fourth answer. Fourth answer, right? Right. Okay. So then let's move on to the sixth question. A bird flying at a 40-meter with a speed of 10 drops a small fruit from its mouth. Its free fall is assumed the speed of the fruit just before it reaches the ground. Right. Now let's consider this one. Now, and bird is carrying a fruit, and the bird is flying with a velocity of 10. Right. So obviously, this object also experiences the a velocity, but horizontal velocity with the value of 10, right? So when it's released or it is dropped, that means today this object experience and projectile motion, something like that, right? So then, just after releasing the object from the bird, the object have two difference of velocities. The first one is directed horizontally, and another one that is directed vertically. However, the as the bird drop the object, the initial vertical velocity should be 0. So then, when it's come to the when just before the collide with the ground, this object should be also have experienced two velocities, that is vertically and the horizontal velocity. Let's call it as Vx and Vy. Okay, Vx definitely should be equal to 10. And make a because you know that the horizontal velocity component of a projectile motion remain constant throughout the motion. So that's why Vx also equal to the initial horizontal velocity, right? So this one also equal to 10. Then we have to figure out the Vy. So to obtain Vy, let's assume let's apply an motion equation vertically. So what is the best vertical equation that we need to use here? We have an idea about initial velocity, final velocity, and the height. But then obviously the velocity, the equation should be this one, isn't it? Right. Then Vy squared equal, hence Vy can be obtained as 20 ms minus 1. So the question is asking about the velocity just before it collide with the ground. No? So today, you already know that just before the collide with the ground, object experience and two velocity components. First one is 10 in a horizontal way, and second one is the 20 in a vertical way. So how to obtain the resultant velocity? Resultant velocity can be obtained by using this equation. Isn't it? Right. So this is the best answer for this question. Um, sorry, here it should be 40 meters, right? Then uh, it should be root 800. So if I apply substitute the value of this to this equation to be this, this is root 800, right? So we have to consider here as the square of the root 800. Right. So here this equal to 900, then the answer should be the 30. So the answer should be fifth one for the sixth question. Right? See, these are very simple questions. The thing is, you have to be very keen idea about this kind of simplifications, right? So then let's move to the seventh question. Figure shows 5 displacement time curves for 5 different objects. The object which has an acceleration in direction of its motion is represented. Right. So the acceleration towards the moving direction. Right. So then these things that you need to know when before obtaining the answer, right? ST graph represent the gradient of the ST graph or the displacement time graph represent the velocity, right? So if they given something like this, that means gradient is constant. Okay, this one is a gradient is constant, right? So if the gradient is constant, that means velocity also should be constant, right? So this one is incorrect. And if they given the ST graph as here like this, that means it's obviously the gradient of this graph is zero. Then the velocity also is represent zero, right? So if this one is incorrect, that means if they given this kind of graph is also is incorrect, right? Because this represent the gradient. It is of this one is a positive, this one is a negative. But even it is a constant, gradient is a negatively constant. So that's mean the velocity also negative and a constant value, right? So when you describing a gradient, you should be consider whether it is a positive or negative. And the other thing is whether it is increase, decrease, or constant, right? There are two things that you need to concern when explaining a gradient. First, you have to consider whether it is a positive or negative. The other thing is whether it is a constant gradient increasing or decreasing, right? So this type of graph, you might remember that okay, this kind of graph represent the gradient is positively increase. Positively increase mean velocity is also positively increase. That means obviously a acceleration, isn't it? So the answer should be the E graph. That means fifth answer. What is the representation of the C graph? That is something like that. This means that if we let's consider that about the gradient, this gradient represent positively decrease, right? So this one represent the positively decrease. So that's mean the velocity also positively decrease, right? So the question is asking about the velocity, the relevant graph, which is increasing the velocity, no? That's mean acceleration. So the obviously this one is the answer, right? In the eighth question, figure shows velocity time curves for three particles A, B, and C moving along a straight line. If all t equals 0, all the particles can be found together at a certain point on the straight line. Then after t equals t equals 10 seconds, what should be happen? Right. Right. So according to theory, if the if three particles meet at a certain distance, and if they initiate the motion at a certain point, so displacement of these three particles should be equal. That's about the theory, right? So if they meet at a certain point, the displacement traveled by these three particles should be equal, right? So then to obtain that, we have to consider the displacement trying obtained by this graph. So obviously, we can able to obtain the displacement of the C graph because we can able to consider the area of this graph, that is should be 50, right? So when we come to the C and B, so at this 10 seconds, they didn't give given the exact values for this the velocities. So that's mean okay, we have to consider just a rough idea about the graphs, right? Then the- but it's better to it's better if they given the certain velocity values after 10 seconds, especially for the B and C. It's all A is already is given, so it's a constant one now. So by looking at the area of these graphs, so we can able to figure out that we can able to think that the displacement of the or the area of these three graphs should be having a difference value, isn't it? right? So that's mean the displacement displacement traveled by these particles should be having a different values. So that's mean um, none of them meet again, right? So that's the conclusion that we can able to come when looking at this graph, right? So the answer should be the fifth one. Right. In the ninth question, which of the following curves correctly represent the corresponding velocity time graph for the given displacement time graph, right? This is the given displacement time graph. Right. So the gradient of a displacement time graph represent the velocity, right? So in this instance, we can able to figure out that the velocity is the gradient of this from A to B. From A to B is a constant one and it is positive. From B to C, gradient is negative and it is constant. From C to D, gradient is 0. And from D to E, gradient is positively and it's constant. So if the gradients are according to this one, so the velocity obviously equal to gradient. The velocity equal is a constant one and it should be positive. This one negative, but it's a constant one, velocity, right? So let's draw the relevant graph for this one. From A to B, the velocity is positively constant, right? From C to B to C, velocity is negatively, but it is constant. Then from C to D, velocity is 0. Then from D to E, it is positive and constant. So the best answer should be the is it 2 or 4? Today you can able to figure out that so the now the answer should be either 2 or fourth one, right? So how should we differentiate the difference? How should we differentiate these two answers? Today, now this is not correctly demonstrated, right? Today, if let's assume that if AB is parallel to DE, if AB is parallel to DE, that means gradient of these two instances should be constant. උදේ gradient constant නම් velocity මොකද වෙන්න ඕන? Constant. එහෙමනම් මේ කතන්දරේ මේක හරියටම පේන්නේ නැහැ. හැබැයි මේක පොඩ හොඳට ඔළුවේ තියාගන්න පුතේ. හරිද? මේක කොහොමනම් මේ දෙක if AB DE parallel නම් so then this value should be equal. හැබැයි එහෙනම් උත්තරේ දෙක. Then but if it is the if this gradient is not equal this one, then this should be drawn like this. But if you carefully observe this question, I think AB and DE are parallel. So that means gradient are equal. That means velocity also should be equal. Then, if it is, the answer should be the fourth one. But I think this one is the fourth one, but both can be accepted as correct because we can't able to differentiate the difference between the AB and DE. That's the only reason, right? So if this graph is given in a magnitude way, then you can able to figure out the difference. You can able to figure out that whether these lines are parallel or not. And keep in mind that I will add some special things for this question. Okay, let's consider two graphs. Let's consider the gradient of this graph and one and this one as M2. So which one having a greater value? M1 or M2? So if there's a rough slope, that's mean the gradient should be having a higher value, right? So you also have to should have some knowledge regarding those stuffs, right? When answering for the questions, right? So the 9 should be the best one should be the fourth, but you can able to accept the second one too. Due to this given graph is in magnitude wise is a small one, right? So then that's why you can able to figure out you can unable to differentiate these two lines. That's why I obtained these two answers as the correct one, right? Okay. 10th one. Which of the following graphs best represent the variation of velocity with time of an object being brought to rest by a constant resultant force? Right. So then you might know that F equal mv. So if the force is constant, and the acceleration also should be constant, right? Then this object should be experience and a constant deceleration. Constant deceleration means the velocity is getting reduced in a gradual way, right? So the answer should be what does mean? This means below. If we consider the gradient of a PT graph, this gradient represents a negative, but it is constant. Then obviously acceleration also negative, but it should be constant, right? So the best represent is third one. Right. In the 11th question, the distance traveled by an object falling freely from rest during first, second, and third seconds in the motion. Right. So let's assume that if the object falling freely, that means the initial velocity is equal to 0, right? So let's assume that this is the distance traveled by first seconds. This is the location of the object at the third second. Obviously, let's assume that this is the position of the object after 3 seconds. Okay, you keep in mind that the distance traveled within these each second should be gradually increased, right? So let's call this one as x, this one as y, and this one as z, right? So let's apply an equation from I will put some letters to define these points. Let's apply an equation from A to B to find the value for x. Then it should be plus 10 1 squared. That means okay, x should be equal to 1. If I apply an equation from A to C, the same equation, then it is y equal to 1 into 10 into 10 to square. Then the answer should be the 20 meters. Then if I apply an equation from A to D, then Z should be equal to 45 meters. Right. But the question is asking about the distance traveled by the object during first second. It's obviously equal to 5. What is the distance traveled within the second second? So then second mean this is the representation of the distance traveled within second, right? So that's mean to obtain the answer you have to you have to consider the subtraction from y minus x. That's mean 20 minus 5. So that's the distance traveled in second. Distance traveled in second. So how should we obtain the distance traveled in third second? This is the representation of distance traveled in third second. That's mean x minus y, isn't it? Then 45 minus 20 is equal to 25. This is the distance traveled in third second, right? So if I consider ratio 5 to 15 to 25, that's mean 1 to 3 to 5. So the answer should be the fifth one. Right. Right. In the 12th question, when two objects A and B move with uniform speed towards each other along straight line, they get 5 meters closer to each other every second. That's mean let's assume that these are the velocities of the object n. Obviously b should be greater than u, so that's why they getting close to each other. They get 5 meters closer each other every second, right? They get closer 5 meters in each seconds. If they move in the same direction along a straight line with the original speed, they get 1 meter close. Alright. So in this instance, the object is moving towards each other and they get closer 5 meters in each seconds. Then if they move in the same direction along a straight line with the original speed, they get 1 meter closer. Right. Okay, let's consider this one in a very simple way. So let's assume that distance travel in 1 second. If the object for this object is v, the velocity of this object is v, and this one is u. Right. So then let's consider the distance travel in 1 second. According to this, C equal ut. V is the velocity and time is v. So then we can able to consider that the distance traveled in 1 second is v for this object and this one is u object. So if they close enough from 5 meters in each second, that's mean today v plus u can be considered as 5. And let's assume that this is the travel of this object in a 1 second, that is u. This one is v. So let's assume that if v is greater than u, then the subtraction or the difference between these two should be represent the 1. Then let's consider this equation as a simultaneous equation. So let's add each other. Then 2b equal to 6. Then b put it together. It should be 3. And the other should be the 2. So the answer should be 2 or 3. This can be 3, third one or fifth one. Right. Okay. In the 13th question, the displacement of a particle measured along the x-axis with the time is shown figure. The magnitude of the velocity of the particle is largest when it travels from. Right. Now here you have to consider the value of this velocities. Right. Let's consider the AB. Okay, when we consider AB motion, you can able to figure out that how to obtain the gradient, of a given graph, that is delta y by considering delta y over delta x, right? So in order to obtain the gradient for AB, you have to consider the delta y. Delta y means to take this one. Then it is equal to 6 divide this one equal to 4. And let's consider the gradient for BC. So when you find in the gradient of the BC, you have to consider this this one divided from this value, right? So then delta y can be considered as 9 over 9 over 4. From C to D, gradient should be 0, right? From D to E, gradient should be 6 over 4, right? This one, EF. So when you obtaining the gradient of EF region or the EF graph, you have to consider this one divided from delta x. Then it is 3 over 3 over 5. So this is 3 over 4. Right. So these are the values. So by looking at this gradient, the 5 gradients, you can able to figure out that which one having a greatest value, right? So the velocity obviously having a greatest value between B and C. So the answer should be the second one. Right. So in the 14th, you also have to draw the a velocity time graph relevant to this displacement time graph, right? Right. these are very simple questions. If you're familiar with these questions, you can able to obtain the answer very easily, right? Right. In this instance, right, something like that, right? So then the what is the thing that we need to do is we have to consider the gradient. So in this is the gradient is a constant one. Gradient is constant and it is positive. Obviously, the velocity should be also constant and positive. When you come to this one, the gradient is 0. Okay, that means if the velocity is, if the gradient is 0, obviously velocity is also 0. Right. If when we come to this one, the velocity, the gradient should be a constant one and it is negative. This one represent the 0 gradient and this one also represent the constant, but it is positive. Okay, how to obtain the positive or negative? That means the angle subtended with the positive direction of the x-axis is acute one, then the gradient is a positive one. Make it hard. So this is the positive direction of the x-axis. So if this angle is acute one, then the gradient should be positive. If the graph is given like that, so then this is the angle subtended with the positive direction of the x-axis and it is an obtuse angle. If it is obtuse, then we consider that the gradient as negative. That's the theory, right? So then, okay, if I draw the relevant graph, relevant dt graph for this above ST graph, positively constant 0, negatively constant, then it is another 0, then it is positively constant, right? So then now we have a question that the value of this instance. So let's consider this velocity as v1 and this one as v2. So we have to figure out that which one having a greater value. If it is v1 or equal v2, then this should be drawn which equal to the this one. So if v1 is greater than v2, this should be drawn something like this, right? So then we have differentiate which one is the correct one. So then you can able to figure out for there. Now, if you consider the gradient of this graph or the slope of this graph, definitely you can able to figure out that this one having a greater slope than this one, isn't it? So if the slope is increased, that means gradient also is getting increased, right? So then, if this graph having a greater slope, that means v1 is greater than v2. So that then this is the most accurate if velocity time graph. I think they didn't given the correct one, but overall, fifth answer can be considered as a correct one. But even though this is the best representation for of the velocity relevant with this graph. So if these lines are parallel, then the fifth answer can be accepted. But the thing is, you can able to figure out that these lines are not parallel each other. Just draw a line from using a ruler like this. Then you can able to figure out whether these are parallel or not. These are not parallel, no? They're not. Right. So this is the answer for the fifth question. Even though this is the fifth answer, not the accurate one, right? So this is the best representation for this relevant with this displacement time graph. So I think it's better to take the answer as all, because not the given, the most accurate answer is not given in the answers, right? So fit 5 or all. Even though this question is given all, you have to be very familiar with this simplification or these kind of detections, right? Right. So in this 15 question, you have given a velocity time graph. And the thing is, you have to draw the relevant displacement time graph, right? So then, in this instance, let's figure out what happened to the velocity. In this instance, velocity is positively, these values are in positive axis, but it's getting reduced. Here, the velocity is positively, but it is increased. So then, gradient of this time displacement graph should be positively decrease, and this one positively increase. So the best representation should be positively decrease means this one, and positively increase means this one. So the answer should be the third one for the 15th question. Right? Right. In the 16th question, now here also given the velocity time graph, you have to draw the suitable displacement time graph. Right. Let's differentiate. Today, in this instance, velocity is positively decrease, isn't it? Positively decrease. Here, velocity is in negative axis. That means negative, negatively increase. Here now, the gradient of the displacement time graph also positive decrease, and the gradient should be negatively decrease. So if it is, the correct answer should be the positively decrease, negatively increase. Right. This is the best answer. So the answer should be the second one. Right. In the 70th question, which of the following, which of the velocity time graph shown below would the average velocity over the entire period between T1 and T2 be equal to the average of the two velocities at the ends of A and B interval? Right. Okay, this one is something, this one it is also is very easy, but even though, so now the question is asking about the average average velocity over the entire period between T1 and T2 equal to the average of the two velocities, right? So they average, if they normally we obtain the average velocity as by dividing two of the addition of these two velocities. So this one can be obtained only in the fifth trial terms, right? Because others are having a different shape. Only the fifth answer having a constant shape, right? So that's why answer should be the fifth one. Right. 18. A particle T moving with constant velocity of 4 along x-axis, the origin O at t equals 0. A second particle Q moving along the same direction with a velocity of 5, passing origin O at t equal 1 seconds. Right. So this is past the at t equals 0, and after initiating this object, after 1 second, another particle which is represent q is passing this position with the velocity of 5. But keep in mind that the second object, that is q object, pass this point, this plane up at the 1 second. So that means this object having a 1 second delay relative to the p. Particle q will reach the particle p when they have traveled distance of right. Okay, that means this is the p and this is the q. When the q, now you can able to figure out that the q object having greater values now. So when they move towards the same direction, this q can be at some instance q can be past the p object. So at least assume that at this particular point q object or the p object is passed by the q object, right? So then if they both initiate the motion at the same time, the distance of the both object having a same value, right? Even though, let's assume that the time traveled by the p object as capital T. Of then, what is the time traveled by the q object? It is obviously t minus 1, right? So this is the thing that you need to highlight, right? About the time. Then now they moving in a constant speed now. So then we can able to apply S equal ut for the both object, right? For the p is equal ut, it's equal 4 into t. For the q, it is x equal to 5 into t minus 1. So the both these equations are equal each other, then we can able to equalize these two equations, right? Then t equal, we can able to consider that t equal to 5. Then x should be 4 into 5, so that means 20 meters. So our answer should be the third one. Right. The 19th question. Figure shows displacement versus time curve for a motion of a particle. Consider the following statement made about its motion. Now this graph is given as a displacement time graph, right? So it also should be keep in mind that when obtaining the answers, right? So let's draw the graph. Right. During period t0 to t1, the particle moves at a constant acceleration. Okay, just first of all, just note down the things that we can able to taken from this graph, right? So now this is the displacement time graph. So the gradient of this graph represents the velocity, right? So let's consider the gradient. If we consider the gradient of this graph, it should be a positive and a constant. This one gradient is 0 and this one represents the constant even though it is a negative one. That means the velocity for this part should be constant and 0. This one velocity should be 0. This one velocity constant but it is a negative value. Right. So can we able to consider the motion from t0 to t1 as acceleration? No, Bhute, because the object from 0 to t1, object travel in a constant speed, right? So if there's a constant speed, that's mean acceleration of this object should be 0. In the A statement, if the object is constant, if the velocity is sorry, if the velocity is constant today, with acceleration equal to 0, the first A statement should be incorrect. During the T2 to T3 moves constant velocity. That is correct. The second part of this A statement is correct, but the first part is completely false one. So A is a false one. B, particle come to rest at T equal 4. So there, if we draw the relevant velocity time graph for this motion, this is a positive constant. T1, and this remain rest velocity at T0 at up to T3. Then is what happened? Object moving in a constant velocity but in a negative value. That's mean at the T4, object having a velocity, right? Even this graph come to the 0, that doesn't mean the velocity is come to the 0. Okay, that's why I normally construct the velocity time graph for this motion. So according to this graph, you can able to figure out that at the T4, the object having a certain value of velocity. So the B also is incorrect. C, during the time period T0 to T4, the total distance traveled by the particle is equal to the area of ST curve. Okay, that is correct. Incorrect, no? Because area is related with the velocity time graph. This is given, this is a displacement time graph. So we can able to obtain the displacement by obtaining the area, right? But just think about this y values. Then you can able to have idea about the displacement, right? So the answer should be the fifth one. Every statement are incorrect. False one, right? In the 20th question, a person simultaneously drops an object and throws another object vertically downwards from a certain height. Which of the following graph best represent the velocity time curves for this object, right? Now, curve A represent the drop of the object, and curve B represent the thrown object, right? So they just consider the theory for this question. Now, the A object is dropped. That means the initial velocity is 0. The second object, that is B, is thrown vertically downwards with the initial velocity. Even though this both object move downward with the gravitational acceleration. So the acceleration should be constant. So you might remember at a in the first question, in the first few questions, at a certain instant that I mentioned that even there's a high initial velocity or greater initial velocity, if there's a fall due to the gravity, the acceleration experienced by the object is equal, right? So then the acceleration of this graph should be, or the acceleration of this object should be equal, right? Now we have to draw the velocity time graph, right? Velocity time graph. The gradient of the velocity time graph, I use M to represent the gradient, right? Gradient of the VT graph represent the acceleration. So both this object having a same acceleration, then the gradient for these two graphs should be equal. But what the difference? This object have the initiate the motion at rest, and this one having a magnitude. Then, if I draw this one as, so let's consider the velocities which is directed vertically downwards as positives. Then, if this is a graph for A, the B graph should be drawn like this because initially there's a value. initial velocity as v naught. This is the v. Even though these graphs should be parallel each other because the gradient of this graph is having an equal value. So the best answer for the 20th question is first one. Right. In the 21st question, you have given a velocity time graph. Right. Now the question is asking about to draw the relevant displacement time graph. Right. Okay. Let's clarify this graph. Now you can able to figure out that the way what happened to, let's call this A, B, C, and D. So what will happen to the velocity from A to B? Now I am asking about the velocity. So then velocity can be obtained by considering the y-axis. So from A to B, velocity is reduced. Velocity is obviously reduced, but even though velocity is at positive axis, so that means gradient the velocity is positive, but it is reduced. So that means gradient also should be positively decreased. So at this from B to C, velocity is 0. That means gradient of a ST graph also equal to 0. In the CD graph, the velocity is at in the positive axis and it is getting increased, isn't it? It is positively increased. So if it is, the gradient should be also positively increased. So the best represent for this graph is this is positively decreased, and gradient is 0 and positively increased. Right. This is the answer for this question. That's mean for the answer should be the big one. Right. In the 22nd, the photographs of an object that start falling freely from rest at t naught t is equal to 0 are taken by a camera. First t equals 0 and thereafter at the end of each second. Which of the following diagram correctly indicate the location of the object at the end of each second? The vertical axis of the diagram represents the distance traveled by object, right? So you might remember that once I sort out, I obtain the distance traveled in each times. I think in the question 11, right? In the question level, in the 11th question, I simplify the distance traveled in each object, right? So by considering that one, you can able to figure out that the distance traveled in each times, right? So according to this question or this simplification, you can able to figure out that the best represent chart should be the fourth one, right? Because it is very easy to find where just apply this equation. So after 2 seconds, object should be obtained 20 meters, right? At the 1 second, the same calculation can be done by considering the 1 second. So the answer should be this fourth one. Right. In the 23rd question, now you have to obtain the displacement time graph for this given velocity time graph, right? Right. Now we have to obtain the velocity time, the displacement time graph. No? So from A to B, what happened to the velocity today? Velocity is positively increased. That means gradient should be represented in the displacement time graph also positively decreased. From B to C, velocity is constant. Velocity is constant and it is a positive value. So then the gradient of the displacement time graph also positive and constant. So what happened to the velocity in the CD? What happened to the velocity in the CD? The velocity, right. So I will consider this point as D. From C to D, velocity is positively decreased. And from D to E, velocity is negatively increased. Here, the velocity is negatively decreased today. But the velocity, the magnitude of the velocity, the y-axis is reduced now. Right. So then, here the gradient of the displacement time graph also positively decreased. Here, gradient should be negatively increased. This one also negatively decreased. Right. So the relevant graph should be first one positively decreased. Right. Then positive but constant. Right. Then positively decreased. Something like that. Then what happened? This is A to B, this is B to C, this is C to D. Then what happened? Negatively increase. Negatively increase today is represented by this one. Negative decrease. Then sorry, negative increase. And then what happened? Negatively decrease. This is the graph for this question. Then today it should be right. It should be either 1 or 5 no. But you can able to figure out that the displacement of this in the positive area is greater than the negative area. So that's mean object doesn't come to the initial position. So that's mean fifth one is the best answer, right? So if this area is greater than the above one, then obviously this this graph should be go beyond this line. That's mean if it is, then the answer should be the first one. But here the area of this shaded area is greater than the below one. So then obviously that's mean object doesn't come to the initial position, right? Okay, so that's the answer for the 23rd one. Let's move on to the 24th question. Two straight lines shown in the displacement time graph represent the motion of two objects A and B started from rest at t equals 0, moving along the positive direction. Which of the following statement made out about the motion of the object is true? Right. So I will then now very carefully notice that what is this graph? It's a displacement time graph, right? This is the motion for A. This is the motion for B. Right. This is for B. Okay, now keep in mind that the gradient of this ST graph is express the velocity, and then you can able to obtain a value for displacement by looking at the y-axis. the object A has traveled for a longer time than B. No, okay, both this object travel in constant time, isn't it? That means the first one is a false one, right? Both objects travel in same distance, sorry, same time durations, right? So when t equal t naught, yeah, object B has made a displacement greater than B. So then, in a displacement time graph, we can able to obtain the idea about the displacement by looking at the y-axis, right? So hence, uh, this is the distance traveled by the B object. This is the travel by the, this is the distance traveled by the A object. Then obviously, B statement should be incorrect because A has displaced more than the B. In the third sentence, object A has a greater velocity than B, right? Okay. Now velocity can be obtained by looking at the gradient, right? So if you consider the gradient of these two graphs, which one having a more slope one? So obviously A. So gradient A is greater than gradient B. So if it is, velocity of the A object has a greater value than the velocity of the B object. So the third answer should be the correct one. Right. In the 25th question, right. So in the 25th question, position of three motor cars, 1, 2, 3, traveling along three parallel straight lines of a road at a time t equals 0 and t equal t naught are shown in the figure. And their corresponding velocity time graphs are shown in the figure. The situation shown in the figure A could be have happened only if the areas of the graph satisfy the conditions, right? So then, now you can able to obtain this the first equation. The distance traveled by this all the three cars are equal. Then the other thing is by looking at the velocity time graph, you can able to obtain that by considering the area, you can able to obtain the distance traveled by the object, right? So if the distance traveled by the object are equal, then the area which is related with these three graphs should be equal, right? Now let's consider the distance traveled by the third vehicle or the third car can be obtained by considering the area of this triangle, and distance traveled by the first car can be obtained the area of this trapezium. Then, by considering the area of this trapezium, uh, we can able to figure out the displacement traveled by the second vehicle, right? Right here, in you can able to figure out that for the all the object, this shaded area is included, isn't it? For this all the when we considering the area for this first, second, and third cars, this shaded area is included. That's mean today the so now if we consider the for this one as so this triangle, it is considered included this shaded area plus BDC plus ADB. And for the first trapezium, it is included this shaded area plus EDF plus and FDG. For the second object, it is included the shaded area plus DBC and DFG, right? So by considering I consider the third the motion of the third car, it is included the shaded area. I represent it from X side plus PCD plus ABD. It should be equal to, if we consider the second object, shaded area plus, for the first object, for the first car, X plus D EX plus DFG. It is equal to the, if we consider the second object or second car, shaded area plus BCD plus DFG. Right? Right. So this is the simple equation that we can able to obtain. Then so by looking at this one, ABD can be equal to DEF. ABD can be equal to DEF. Then ABD equal to DEG. Now, the DEG means this whole area. No, that's mean this both one. Yeah. So take when you need AB, the mega when put that. The simple thing is these two can be equals this one, or this the sum of these two can be equal to this one, or the sum of these two can be equal to this one. That's the only thing, right? So you might be able to consider the ABD equal to DEF. It might be, but it doesn't equal to the ABD equal to DEG, right? So it is incorrect. So in the second answer, BCD equal DEF, right? And ABD equal THG. All right, it is correct now. So second one is correct one, isn't it? So let's move to the third one. CDB, this one. CDB can be equal to DFG, right? And ABD can equal TF. Okay, this we can able to equalize two different things. But so for the third answer, all the three are included. So we can't able to obtain an expression by considering all the three. We can able to derive an expression by considering only the two instances. So that's why we can able to obtain the answer as the second one.